Hello and welcome to Easy Projects. So a few people have asked for a tour of the shop here, or lab, or whatever you want to call it. So today we will take that tour. So I think I'll just pan the camera around and zoom in on a few things and say a few words about them. And if there is anything you want to see a video about, you can leave a comment in the comment section and I will think about it. And what you see here is my workbench. And as you can see, I have my DC load lying there on the bench, and I am currently working on that again, so there will be an update video very soon. And for that I'm using my oscilloscope. It is a Rigel DS1052E, and I have been very happy with this scope actually. And it have dropped a lot in price since I bought this one, so you can pick it up very cheaply these days. And if we just pan over here, you can see I have my power supply, and that is an HP E3632A, and as you can see it's a 0 to 15 volts 7 amps or 0 to 30 volts 4 amps. It is only a single channel, but it has these sense terminals, so you can bring a wire directly to the thing you're powering and get the feedback from there, so you don't have voltage drop over the cables. This unit is fairly old, but I believe they actually still make them, the exact same model. And if you want to see some pictures from inside this unit, I have some on my website, easy-projects.com. And sitting on top, we have the bench multimeter. And that is a Fluke 8846A 6.5 digit precision multimeter. And apart from it being very precise, I like the features that it can draw graphs on the display, and it has very good data logging as well. And over here I have my soldering station, a Hecode FX888. But this might actually be a clone, I'm not sure about that, but a few people have commented on the video about the Atom soldering station that I did, where I took this apart, that they can see from the PCB that it is a fake. But if I get time I might investigate that a little bit further. But yeah, they are probably right. It might be a fake. And moving on, I have a hot air rework station. And that is a very cheap unit, but it does the job, so I don't really use it that often. Underneath I have my homemade power supply. And I have already done a video about that. And there in the background you can see a bunch of my tools, some side cutters, pliers, calipers, and so on. And behind the computer and the scope I have my screwdrivers, or the ones I use most frequently, that is. And as you can see I have 3 of these power strips at the back of the table, so there is always some power nearby. And of course you gotta have a pile of crap on your bench. So let's take a view at these shelves here, shall we? If we zoom into the corner, you can see my interestingly old signal generator. There is actually not a single integrated circuit in this thing, it is all discrete components. We might actually take a look inside that one day, because it is a bit funny to see how they did everything back then. Moving on, I have 2 of my multimeters, a Unity and a Velleman multimeter, and they are also fairly cheap, but they do the job. And this little red thing here is a light meter, and that will basically measure light in lux. I have the EEV block microcurrent, and that comes in pretty handy when you're measuring the current consumption of low voltage circuits. Because if you use a multimeter you'll have some voltage drop across the sense resistor in the multimeter. And Dave Jones, who made this, have optimized it so that this resistance is as small as possible in the microcurrent. And moving on, I have my DIY transistor tester. This guy, the grey one. I also made a video about that. An OBD scanner for my car. all the soldering accessories, solder flux pens and bottled flux, a propane torch, or at least the small one, and there's a micrometer in the background there, a pair of helping hands, and the IMAX B6, which is also fake, and I discovered that fairly soon after I got it. So let's jump up to the next shelf. Oh, actually there's something behind the box there. And that is an old analog multimeter. And no, I never use that, I just have it. So let's jump up. Some colored electrical tape. That is always handy to have when you have to mark things up. The Atom soldering station, and I never use that either, because it's crap. And this is actually a current limiter for my home-built power supply. But I tried to build it only using very cheap components, and I wrote some comments about that also, but I never really got it to work as good as I wanted. Well, it does work, but there's a little bit of ripple when it is in constant current mode. So if you set the current to, say, 100 milliamps, it might jump from 95 to 105 milliamps. I wanted it a little bit better than that, but I never actually got it finished. But who knows, I might still do it someday, I don't know. And moving on, here I have my boxes where I store components. You can see there's some springs and standoffs and everything in this box. And the lower one is full of displays. We can move on. I have some LEDs and LED displays in the bottom one there. And the top one here have some electrolytic capacitors, test leads, some ICs, and the small one at the bottom there has some crystals and oscillators, all kinds of connectors, battery holders, and some surface mount components in the middle one, and all caps that are not electrolytics. So I guess that's basically it. Oh, and down here I have a ground post, so that's just that one there, and all the connections are just connected to ground. And also the anti-static mat on the table, that's also connected through to ground. And there's also 2 ground outlets on the connector on the mat there. I don't have my power supply grounded, but if I need to, I can just plug in a banana cable to the green terminal there. And a few test leads. And moving on, there is the component cabinets. And I basically have a drawer for every single value of the resistors from 0.1 ohm to 10 megohms. And I have the E12 series, so I could probably have just 12 drawers and then have each decade in a bag for itself, so I could have all the 4.7 ohm, 47 ohms, 407 ohms, 4.7K and so on in one drawer, and then repeat that for all the other values. But I really hate when I have to look through all these bags, so I decided to go with a drawer for each value. And down here there's just some random stuff, some high power resistors, some sockets and some microcontrollers, a few op-amps and MOSFETs, rectifiers, 555 timers and 556, and some switch mode converters in this drawer here. And that's just these cheap ones from China, but they do work. A whole bunch of empty drawers, and down here I have some other ICs, inductors and microphones, some sensors and my fuses. And I also have a bunch of crap on the top. There's a few solenoids, some big ass push buttons, and some small 7-segment displays. And just because you have to have one, a mini hand plane. The light switches, and a door that leads to who knows where. Here is my 3D printer and all the filaments and whatnot, but I usually move it to the main bench when I'm filming it, just because that is more convenient. And something I haven't told you yet, a laser cutter. I actually meant to do a video about this long ago when I did the electronic DC load, because I wanted to make the enclosure out of acrylic plates. But yeah, then the first circuit didn't work as I expected it to, and I first got the time now to redo the circuit, so I kind of wanted to do it as a surprise video, but yeah, now you know. But I will do a video just about the laser cutter, of course, when I finish this new circuit for the DC load, and it is working better this time. There's still a few problems, but I won't do another revision. I'll just live with this one. And there's also coming a video about that very soon. But why not just take a sneak peek? Oops, there goes the 3D prints. It is actually not that complicated. There's just a laser tube in the back here. We can't see that right now. And the beam is reflected off 2 mirrors and down into this 3rd mirror and directly down to the substrate that you are cutting through. And then this arm will move, of course, and this head. And as I just said, a box of 3D prints. Most of it is garbage actually, but something like this is actually a pretty nice little thing. It is a screwdriver where you can just install individual bits. And this is made out of nylon, so it is very strong and it won't break or do anything. And underneath the laser cutter there's a water cooling for it and another little pile of junk. And that is actually another power supply. That sorta kinda works, but it is just too big, I think. So I don't use that either. And there is more shelves over here. It's not all for my electronic stuff, there's also some screws and bolts and so on. But in this DigiKey box over here I have some speakers. There's some mains, wires and plugs in the box to the right. Some old enclosures. And a pretty decent AKG wireless receiver for microphones, but I don't have the transmitters, so I can't really use it. All the bolts and screws. Some bracing and welding flux for brass and aluminium. And we have my old analog scope, and I don't really use that much either. And on top in these 2 rolls I have my photoresist and solder mask for doing homemade PCBs, and also the glass plate that I put on top of the circuit boards when I'm exposing them to the UV light. And these boxes here is where I used to have my resistors and capacitors and so on, but the ones with the resistor values on them are actually empty because I moved that to the component cabinets. And it is a lot easier this way, trust me. I think the most annoying part is that these boxes are double-sided, so I have to flip them if I want one of the other values, and that just annoys the piss out of me, so I bought the cabinets instead. But I still have the capacitors in the box saying caps, and I have some ICs, some switches, diodes and Zener diodes, and there's actually no fuses in there either, they are also in the component cabinet. Transistors, FETs and regulators, and electrolytic capacitors. So for these components that I don't use all the time, it actually works out pretty good to store them this way. So for the transistors, as an example, I just have the NPN in one row and the PNP in another row. And for the switches, yeah, I just kind of keep the same type near each other. But yeah, it's not very organized. Some is taking up 2 rooms. And I have my Dremel tool in the blue back there and some batteries. And I tried to boost the hell out of one of these box sappers just for the fun of it, but actually I ended up giving it so much voltage that it arced over inside of the transformer that's in there. So it never really worked. The first time I turned it on, it just welded together the transformer. Oops. I kinda meant to repair it, but I never got around to it, so that's why I didn't throw it out. I have a little box with transformers and stuff, and a few big ass electrolytic capacitors for my upcoming new power supply that I'm planning, but I don't know when that will come. We will see. And those 2 DT-key boxes also contain some components that I haven't sorted yet. And down here I have some enclosures, some fans, more LEDs. These are actually UV LEDs for a UV exposure box that I also planned to build, but I never got around to that either. All kinds of different screwdrivers that I don't use all the time. All kinds of thermal compounds and tape in the upper box there. And some copper wire. And here I kinda just throw my Arduinos when I don't use them. And I also have an embed development board from Freescale. I got it at a competition where I built a remote controlled car / robot with some of my friends. But we kinda had no idea what we signed up for, so this had to be programmed in C++, and none of us had ever tried programming in C++ before, so we spent way too much time programming, but we actually got it to work in the end, with a little bit of help from some of the others, but yeah. So I guess it's needless to say that we finished in second last place. But then again, it was quite fun, and at least we got all the mechanical stuff to work, and the electronics kind of worked also. So the only problem we had was actually the remote control. That was not quite finished when we ran out of time, and also we had to use these ultrasonic sensors to let the car steer by itself in one part of the course, but we didn't have time to implement that either, so we also lost some points there. And I also have a box of glue. And down here I have some potentiometers and trimmers and some heat shrink, a vise, some more fans, and some more cables in that box on top there. You can't really see those, but it's just more test leads. And there is all my wire and my bare PCBs. And down here I have some cardboard, a hot plate, an old laptop, some of my finished projects, and a box of aluminium, and a whole box of resistors. And in this box with the finished projects I have my LED panel, and those are UV LEDs, so I use that for exposing my DIY circuit boards. I have a timer for that. I actually meant this to go into a box, but I realized that these LEDs that I use actually require to be about 20 or 25 centimeters away from the PCB for the light to diffuse properly. And I thought it wouldn't make any sense to put this inside a box, because if I wanted it to be able to expose both sides at the same time, I would need a box that was about ½ meter high, and I thought that would be a bit ridiculous. But yes, that's the timer. I have another small LED panel and these are red LEDs. So I can use this to illuminate the room while I am applying the photoresist and all that kind of stuff, because it will harden under a normal light, so I have to use red light. And there's this little power adapter for electret condenser microphones. But yeah, I don't actually know if this works that well, because I tried to use it with my old camera, and if you remember, there was a lot of noise on that. But I figured out it was actually the camera itself that was noisy, so this might actually be good. The matrix that I used for the multiplexing video, a PIC-based LC meter, and this is not something I designed. I found the circuit on the internet somewhere and I made it a long time ago. The electronic mini game, and I also made a video about this. And this is actually the first PCB that I made myself. It is made from a schematic that I found online, but it is basically just a latching relay that is using a momentary push button as an on-off switch. And the layout is awful, but it does work. And I have two panel meters here that I never finished, and I made these in the do-it-yourself PCB video that I made long time ago. And that pretty much brings us back to where we started. And I also have this old heat press that actually still works pretty good. And I use this to apply silkscreen and when I'm making circuit boards with the toner transfer method. And I have some more crap under the table here. I have the laminator that I use to apply the photoresist and the solder mask. I have a box of acrylic or plexiglass or whatever. And that box is not really supposed to be there actually. And of course you will need a bin to throw the stuff in that you screw up. So I guess that was about it. And as you can see, it is not a very big room at all. But yeah, it works just fine. If you have any questions or suggestions, please put a comment below. And if you like the video, please give it a thumbs up. And if you're not already a subscriber, please subscribe to my channel if you find the videos interesting. And I will see you soon for the next part of the DC load videos. See ya.